This is section 12.4, simplifying rational expressions. First, we're going to look at excluded values. When you look at the ratio of two polynomials, we want to make sure that the denominator does not equal 0, because the expression is going to be undefined when the denominator is 0. So you want to look at what number makes the expression undefined. This is called an excluded value. The variable cannot have this value, or the expression is undefined. So let's take a look at this first example. X plus 8 divided by 10 times x. 10 times x is the denominator. What number can x not be, or the expression will be undefined? Well, x here cannot be equal to 0 because that would make the denominator 0. So 0 is the excluded value. In B, we have 5 divided by 2y plus 14. So when 2y plus 14 is 0, the expression is undefined. So you want to solve for y to see what value it cannot be. So in this case, 2y is negative 14 and y is negative 7. That means negative 7 is the excluded value. In that fraction, y can never have the value of negative 7, or the expression has no meaning. It will be undefined. In C, we have 4v divided by v squared minus 9. To solve for the excluded value, you have to factor the denominator. So factor it to see what values of v is undefined. Now this is a difference of two squares. So you're going to take 4v divided by v plus 3 times v minus 3. So in this case, you have two excluded values, both negative 3 and positive 3. This one's a little more difficult. If we want to find the excluded value here in 7w plus 2 divided by 8w squared plus w plus 5, it will be undefined when that denominator is equal to 0, so you want to factor that to solve it. But the problem is that cannot be factored. So what are we going to do? Well, you can see if there is a solution by using the discriminant. If you remember, the discriminant is b squared minus 4ac. So in this case, it's 1 squared minus 4 times 8 times 5. That is less than 0. And remember, when the discriminant is less than 0, that means there is no solution. The fact that there's no solution means that there's no number for which this expression equals 0. So there are no excluded values here. To simplify rational expressions, you want to factor the numerator and the denominator and divide out or remove any common factors. Now you have to remember here that common factors are numbers or variables that are being multiplied. They're not numbers or variables that are being added, right? They have to be being multiplied by something to be a factor. So the general form is AC divided by BC equals A divided by B. You have a common factor of C in the numerator and denominator, so you remove it. In this example, we have 2x plus 4 divided by 3x plus 6. Factor the numerator and the denominator and identify the excluded values before you remove the common factors. Okay, you have to do that because later on, when you start removing common factors, you're going to lose the excluded values or the ability to see them. So it's really, really important that you stop at that step, get it completely factored, then identify the excluded values, and then remove the common factors. So in this case, we have a common factor of 2 in the numerator. We're going to do 2 times the quantity x plus 2 divided by 3 times the quantity x plus 2. Now determine what your excluded value is. In that denominator, x cannot be equal to negative 2 because that makes the denominator equal to 0. After you determine what that excluded value is, you can remove the common factors in the numerator and denominator. So now we can remove the x plus 2 in both the numerator and denominator, and our final simplified fraction is 2/3. Let's look at some more examples of simplifying fractions. In A, we have 5x divided by 5 times the quantity x plus 2. This is already factored, so just determine what the excluded values are. They cannot be x equals negative 2 because that would make the denominator 0. Then remove your common factors. You've got a 5 in the numerator and a 5 in the denominator. So this fraction becomes x divided by x plus 2. In B, you have 6m cubed minus 12m squared divided by 18m. Here we already have the denominator simplified, so that it's 18m squared. For what value of m is this undefined? It would be 0. So 0 is the excluded term. You want to go ahead and factor it then. In the numerator, you can remove a 6m squared from both terms. So do that, and you get 6m squared times the quantity m minus 2. Divide the whole thing by 18m squared. Then you have something in common in the numerator and denominator. You have a 6m squared in both. So let's divide that out. The numerator then becomes m minus 2, and the denominator 3. In C, we have y divided by 7 minus y. This is already simplified, so you don't have to factor it at all. You can already tell what the excluded value will be, because 7 minus y is easy to determine that y cannot be 7. That has to be excluded, or your denominator is 0. In D, you have something more complicated. You have x squared minus 3x minus 10 divided by x squared plus 6x plus 8. You have to factor this. Factor both the numerator and denominator as best you can. In the numerator, you have x minus 5 times x plus 2, and in the denominator, it should be x plus 4 times x plus 2. So in the denominator, you can tell that the excluded values here are x equals negative 4 and x equals negative 2. Now that you've done that, you can remove the common factors. So you can see in the numerator and denominator, we have x plus 2. So divide those out, and you end up with x minus 5 divided by x plus 4. That is in its simplest form. The key here is to factor and find the excluded values first. Then simplify the fraction and remove the common factors from the numerator and denominator. So you need to go through those steps every single time. You have to be able to recognize opposites, and this is a little more difficult. We're doing the same thing. We're factoring, and we're taking a look at the factors to see if we have the same thing in the numerator and the denominator. But the thing is, sometimes they're not exactly the same. Sometimes they're similar. And if you can just remove a factor of negative 1, you will have the same factors. So take a look at this. It's x squared minus 7x plus 12 divided by 16 minus x squared. When I factor it, the numerator becomes x minus 4 times x minus 3, and the denominator 4 plus x times 4 minus x. Right now, there aren't any common factors in the numerator and denominator, but that's what you want. If you look at it, though, you can see that 4 minus x is the opposite of x minus 4. So we can make them equal by just factoring out a negative 1. And that's what I did on the next line. I factored out a negative 1 in the denominator. When I do that, that second term in the denominator, instead of being 4 minus x, it becomes x minus 4. Now you can not only identify your excluded values, but you have something in common in the numerator and denominator. You know, that's really your goal, is to simplify these fractions. That's why we're trying to do this. So when you identify the excluded values here, it's negative 4 and 4, and then we're going to remove the common factors. So when I remove the common factors, I end up with x minus 3 over 4 plus x. Now remember, you had a negative 1 in the denominator, and you cannot leave any negatives in the denominator. So I move the negative to the numerator. When I have a negative 1 multiplied by x minus 3, that actually becomes 3 minus x divided by 4 plus x. That is in its simplest form. Will I accept the line before that? I will, but I'll probably take a point or two off because it's not in the most simple form that it could be. So you want to actually multiply that out and make it 3 minus x. And the last thing we're going to do here is take a look at a real-world problem. This is the average cost for cell phone use in dollars per minute from 1991 to 2000, and it's represented by this function. The function is given. The cost is 46 minus 2.2x, all divided by 100 minus 18x plus 2.2x squared. You want to rewrite this function with whole number coefficients and simplify. Remember, we've never really worked with decimals or parts of numbers before when we're factoring. So it's much easier to factor when you have whole numbers. So let's multiply the whole thing through by 10 and get rid of those 2.2's. So it becomes 460 minus 22x divided by 1000 minus 180x plus 22x squared. I would actually have switched all these terms around. It really should be in standard form where you have the highest exponent to the lowest exponent. I find it easier to factor that way. The book did not do that. They left it in this form, and you might want to take a look at it there. What they did was they took out the greatest common factor, and of course that's the easiest way to factor. You do want to do that first. So we took out a 2 in the numerator and denominator, and then we removed that common term of 2. And you can't factor any further than that. That's as simple as it gets, believe it or not. Okay. So then they ask you to calculate the cost during any year in this time period. You can because you have this simplified function now. So if you want to find the cost in the year 2000, for example, 2000 is 9 years since the beginning of the period, 9 years since 1991. So you're going to use x equals 9. You should try that and confirm that you can calculate the answer. You should be able to take any time period and plug it into this simplified form. Now, why do we want to do this instead of using the original equation? Because your calculations are much easier. That's what happens when you simplify a fraction. You don't have to do as difficult multiplication. That's really what it's all about, is to make the calculations simpler.